So let's see this exercise, which is exercise 10.15, page 249. Previously, we have seen how to draw the free body diagram and also the kinetic diagram. Okay, now we will go to the complete solution of how to calculate the problem given with the numbers and so on. Okay, not just the figures. Okay, so this one, exercise 10.15, said that a 5 kilogram mass disc is welded. So the disc is 5 kilogram. So here 5 kilogram welded to a uniform rod. This is a rod of mass 12 kilogram as shown. So the mass of rod is 12. This one is 5. Determine the angular acceleration. So you are required to find the angular acceleration. Okay, it didn't say angular acceleration of rod or disc because it is already welded. So it become one rigid body. So one rigid body can only have one omega and one alpha. So that's why in the question said determine the angular acceleration. Okay, meaning that for that rigid body of the system and component of reaction at B. So we are required to find the component of reaction at B. Okay, because at B we know we have two force. Okay, at B, so we are required to find this component of reaction. Okay, with P equal to 50 Newton and the omega is given as 10 radian over second. Okay, so the omega is given, the P is given, radius is given, the mass of the whole component and each of it is given. We are required to find the alpha, okay, and also the component of reaction at B. Okay, so what we'll do is we will start by draw the free body diagram and kinetic diagram. We only have one big equation. From that equation we resolve into x and y and so on. So the equation is sigma f equal to ma. Okay, so from here we will first, for sigma f we will draw the free body diagram, and for ma we draw the kinetic diagram. Okay, so we go one by one. For the free body diagram, as normal, we will start by looking at external forces. In this case we only have one external force, which is P. So you put P here, P which is 50 Newton. Okay, so there's no more external forces. Next thing we'll do is we go to the if the component have mass. So in this case we have two mass, which is two component welded together but two component. So we have 2G, which is the first is center of gravity of the rod and the second one is center of gravity of the disc. So we have 2 mg downward acting on the center of gravity. So the first one we will have downward here m rod, which is 12. No, that's m of rod times g, and the other part will be downward also m of this g. Okay, so we have external forces and mg. Okay, and the last one we will put the reaction force. In this case we only have one part which is touch the other component, which is at point B. So point B is a pivot point, so it is a pin joint. So for pin joint we will put two forces through reaction, which is x and y direction. So we can name it as, the first one is By and the second one is the Bx. So By and Bx. So in this case we can see that we have two unknown here, which is Bx and By. Already two unknown. Okay, we are allowed to have up to 3 unknown in this case. Okay, settled for free body diagram. Now we go to the kinetic diagram. So the kinetic diagram, we have learned that we know that this is a rotation type of motion. So for rotation type of motion, each G we have three component, which is MA normal. We will stick to the MA. So MA, because it is rotation, so we have MA in normal direction, MA in tangent direction, which is at the center of gravity, and also we have I alpha. So we have three: M A tangent, M A normal, and I alpha. All is acting on center of gravity of each component. So in this case, we have two component, 2G, so we will have 3 for each G. So MA tangent, MA normal, and I alpha for this one, and also for this one. So we have 6 components. Okay, so we go one by one. The first one we have already identified. This is G for component D, and this is G for the rod. So we have 2G. Okay, so the first one we want to put the MA normal. So we know that MA normal. The second part that we need to identify is the center of rotation. Okay, so the center of rotation in this case is the B. The center of rotation is the B. Okay, so because the given rod is 0.6 and 0.2, so 0.8 divided by 2, so here will be 0.4, 0.2, and 0.2. So we know the distance here. Okay, I can write here 0. This is 0. Okay, 0.4, 0.2, and the other one is also 0.2. So make it all 0.6. Okay, so the first one we need to put is MA normal, which is acting always towards the center of rotation, from the center of gravity towards the center of rotation. So I want to put here to this one, okay, to this direction. Okay, this will be M of rod, okay, and then times the A at G rod or at G of rod, okay, in normal direction. Okay, this is the first one, and the second one is the tangent. Tangent must be always 90 degrees to the first one. Okay, so in this case you can go upward or downward. Okay, we didn't know, so you have to choose one. Even though the omega is given, but the alpha can be opposite direction of the omega if it is a deceleration. So we still didn't know which direction is the alpha, clockwise or counterclockwise, so we didn't know. Okay, maybe I just assume it will be turning clockwise. Okay, as the alpha is clockwise, so my tangent must be, the first one is 90 degrees to this one, and agreed with my alpha. So I can put it this direction. So this one will be M of rod times A at G of rod in tangent direction. Okay, so in this case, my alpha must be clockwise. So the third part, which is this one, I at G of rod alpha. Okay, so we have 3 components: MA normal, MA tangent, and I alpha. Okay, we have the second component, which is this one. Okay, so we need to do the same thing from the center of gravity towards the center of rotation. So we need the way it is will be opposite direction from this one, because we want to go to the center of rotation. So this one will be, so maybe I'll put it here, which is M of this. Okay, now we're talking about the this. A at G of this in normal direction. Okay, the other one is tangent. So since the omega is clockwise, so the tangent for this one must be 90 degrees to this line, but agreed with the omega. Okay, we can only have one omega. So this is the direction actually for tangent. Okay, because we want the I omega, the omega must be the alpha must be same direction. Okay, so we have here M of this, A of at G of this tangent, and the last part is this one, I of this, I at G of this alpha. Okay, we cannot have two alpha, we only have one alpha, so we must agree with tangent and so on. Okay, so now we are finished for free body diagram and also kinetic diagram. And our equation will be developed for this one, sigma f equal to 8, will be developed based on these two figures. Okay, free body diagram and also kinetic diagram. So if you are not able to draw the correct free body diagram and kinetic diagram, for sure you will have a wrong equation. Okay, for the sigma f equal to 8. If you have a correct one, you might do wrong after that, but at least you already have the correct free body diagram and kinetic diagram.